Download this code from codegive.com, link in the description below. OK, let's dive into XML parsing in Python using SAX, simple API for XML, focusing on event-driven parsing and how it differs from other approaches. We'll use the ZetCode example as a foundation, expanding and explaining along the way. What is XML? XML, extensible markup language, is a markup language designed for encoding documents in a format that is both human-readable and machine-readable. It uses tags to define elements and attributes to provide information about those elements. XML is a common format for data exchange, configuration files, and more. XML parsing methods in Python. Python provides several libraries for working with XML data. The most common are *SAX, simple API for XML event-driven parsing. SAX reads the XML document sequentially. It doesn't build a complete tree structure in memory. Instead, it calls methods in your code when it encounters certain events: start of an element, end of an element, character data, etc. SAX is memory efficient, especially for large XML files. *DOM, Document Object Model Tree-based parsing. DOM reads the entire XML document into memory and builds a tree representation of the structure. This allows you to navigate and manipulate the XML data more easily but consumes more memory, especially for large files. *element tree *, a more Pythonic and relatively memory-efficient way to work with XML. It also builds a tree structure, but typically uses less memory than DOM. It has a simpler API. *LXML*, a powerful and fast XML and HTML processing library. It can use both SAX and element tree approaches and offers improved performance compared to the built-in XML.itree.element tree. Why choose SAX? SAX is the preferred choice when you need to process very large XML files and memory usage is a concern. You only need to extract specific information from the XML document and don't need to manipulate the entire structure. The order of elements is important for your processing logic. You want to avoid loading the entire document into memory. SAX event-driven parsing. The core idea behind SAX is that you register handlers that are called whenever specific events occur during the parsing of the XML document. These events include *start element, name, address, called when the parser encounters the start of an XML element. *name, the name of the element, example book. *address, a dictionary-like object containing the attributes of the element, example ISBN, 12345. *endlement, name, called when the parser encounters the end of an XML element. *name, the name of the element. *characters, content, called when the parser encounters character data, text, within an element. This can be called multiple times for a single element if the data is split across multiple chunks in the XML document. You typically need to buffer the data to get the complete text content. *start document, called at the beginning of the XML document. *end document, called at the end of the XML document. *processing instruction, target, data, called for processing instructions, example XML style sheet. *comment, content, called when a comment is encountered. SAX in Python, XML.SAX. The XML.SAX module in Python provides the necessary classes for SAX parsing. Key classes XML.SAX content handler, a base class for content handler classes. You create a subclass of this and override the event handler methods. XML.SAX make underscore parser, creates a SAX parser object. You can optionally specify the parser implementation to use. XML.SAX parse, file name, handler, parses an XML file using the specified handler. XML.SAX parse string, handler, parses an XML string using the specified handler. XML.SAX XML-reader.attributes, the base class for attribute information. Example, parsing a book catalog, ZetCode inspired. Let's create an XML file and a Python script to parse it using SAX. 1. Create the XML file, books.xml. 2. Create the Python script, parse_books_sax.py. Explanation asterisk. 1 book handler class asterisk. This class inherits from XML.SAX content handler. We override the event handler methods. *__init__, self, initializes the handler. Self.current_data is used to buffer character data. Self.isbn, self.title, self.author, self.price will store the values for the current book. Self.in_book a flag to indicate if we are within a book tag. *start element, self, name, address. This method is called when the parser encounters the start of an XML element. Self.current_data equals, we reset the data accumulator to start accumulating the text content of the new element. If name equals book : if the element is a book, we print a message. Self.isbn equals address.get, ISBN, we retrieve the ISBN attribute from the address dictionary. The address parameter is an instance of XML.SAX XML-reader.attributes_impl, which is a dictionary-like object. Using .get, ISBN, is safer than directly accessing address ISBN because it avoids a key error if the attribute is missing. *endloment, self, name. This method is called when the parser encounters the end of an XML element. If name equals title, if name equals author, if name equals price, if the element is one of the book's properties, we print the accumulated self.current_data to the console. The strip method removes leading and trailing witty space. If name equals book, if the element is book, we set self.in_book equals false. Characters, self, content. This method is called when the parser encounters character data, text, inside an element. Self.current_data plus equals content, we append the content to the self.current_data variable. This is important because the parser might call characters multiple times for a single element if the text is split across multiple chunks. Start document, self, called at the beginning of the XML document. End document, self, called at the end of the XML document. 2. Creating the parser asterisk. Parser equals XML.SAX make_parser, creates a SAX parser object. Parser.set feature, XML.SAX handler.feature_namespaces, 0, this is optional. It disables namespace processing. If your XML uses namespaces, you'll need to handle them accordingly. SAX has features for this. 3. Setting the content handler handler equals book handler, creates an instance of our custom book handler class. Parser.set content handler, sets the content handler for the parser. This tells the parser to call the methods in our book handler class when it encounters events. For parsing the XML asterisk. Asterisk parser.parse, books.xml, starts parsing the XML file. The parse method reads the XML file and calls the appropriate methods in the book handler class as it encounters events. Asterisk alternatively, xml.sax parse string, xml_string, handler, can be used to parse XML data that is already in a string variable. Running the script asterisk. Save the XML file as books.xml and the Python script as parse_books_sax.py in the same directory. Then, run the script from your terminal. Output asterisk. Key improvements and considerations asterisk. Asterisk data accumulation asterisk the characters method accumulates character data. This is important because the parser may call characters multiple times for a single element's text content. We then strip wit space in the end element to clean the data. Asterisk error handling asterisk in a real-world application, you would add error handling, example using try, except blocks, to handle potential exceptions during parsing, example malformed XML, file not found. SAX also has an error handler that you can set to handle XML validation errors. Asterisk namespaces asterisk if your XML uses namespaces, you'll need to handle them in your start element method. SAX provides features for namespace processing. Asterisk large files asterisk SAX excels with large files. You can process gigabytes of XML data without loading it all into memory. Asterisk flexibility asterisk you have complete control over how you process the data as it's being parsed. You can easily filter, transform, or store the data in a custom format. Asterisk in_book flag asterisk this flag is added to ensure that we only process the elements within the book element. If the XML structure gets more complex, you can use a stack to keep track of the current element hierarchy. Asterisk resetting data asterisk in the end element method, the code resets the book-specific data, title, author, price, after processing each book. This is not strictly necessary in this simple example, but it's good practice to prevent data from bleeding over to the next book if the XML is malformed or contains missing elements. Example of handling errors. In this example, a custom error handler class is created and attached to the parser. This will catch and print any warnings, errors, or fatal errors encountered during the parsing process. The try, except block catches the xml.sax SAX parse exception which is raised when a parsing error occurs. When to use SAX versus DOM/element tree. Feature SAX DOM/element tree. Memory usage low-high. Parsing speed potentially faster slower for large files. Random access limited, event-driven, easy. Manipulation difficult easier. Complexity can be more complex simpler API. Best for large files, data extraction small files, manipulation. In summary, SAX provides an event-driven approach to parsing XML documents, making it suitable for large files and scenarios where memory usage is a primary concern. While it requires more code and a different mindset compared to DOM or element tree, it offers significant advantages in performance and resource utilization when handling large XML data sets. Remember to handle character data correctly by accumulating it in the characters method, and to implement error handling to make your code robust. Experiment with this example and try modifying it to extract different information or perform different operations based on the XML data.